guess, yeah, I started recording,
Okay.
and people join little. That's okay, I mean, that's fine because so we have to think about, how we are going to change it now. As I said, always I try to show you some kind of interesting, clip of a movie or something, and the reason is then it really gets you really, it really gives you the background, and then you know what we are talking about now. I tell you this. Probably, I don't know if you're in India, they call it karma. I don't know, last incarnation or whatever. We did such a thing that we are here in Silicon Valley. We have been living here for the last 24 years, and probably some of us more than that. This is the place that changed the world. Literally, this is the place that changed the world. And how it changed the world is a wonderful, wonderful. There's a wonderful documentary and everything. So basically, Silicon Valley. Even yesterday, I was talking to one of my friends. He said, "I said Silicon Valley is not a location; it's a mindset." Because here people just this is the only place in the world where failure is rewarded. So if you start a company and go to a venture capitalist, and the first thing that guy will ask, how many startup you failed earlier, because more startup you fail, if there's a chance of getting better funding. The reason is they know that you failed one startup, so you learned a lot, and then you are motivated enough to start the second startup. You failed the second startup, you're motivated enough to start the third startup too. You have really incredible resilience. You just don't want to give up. That's what the Silicon Valley they want to look for, and plus all the experience you learn. Having said that, all those started how this changed the world in the late 60s and early 70s, and then it just never stopped. And because of this place, it really the first man went to the moon because of Silicon Valley. Of course, rocketry and all those things were there, but a lot of electronic stuff is going into it. Without that, it would moon landing with Neil Armstrong and his team was not possible. So having said that, uh, I am going to start, and the second same thing is going to happen again. What you're going to, I'm going to show you the first 3 or 4 minutes of the movie. It's not the whole movie, but this is your homework. Whoever in India is Sunday, I'll paste the link on the chat. Go and watch the movie. This is your homework. If you don't watch the movie, don't come to the next this thing, because then you're going to miss it. You're going to miss a lot. How everything started, how the innovation. We're talking about innovation, the culture of innovation, how you can really bring yourself in your startup or wherever, if you want to start your career in AI, how can bring the innovation. There's a professor from some engineering college I just heard, sir, you need to bring that innovation culture among your students. Probably you missed that think like a Wright brothers, but that's being recorded. And so basically that is recorded, not being recorded. Today's session is being recorded, so that is already recorded. We'll share that recorded version with you, so please watch with your student. It's absolutely required for today's generation, because things are really happening very fast. So having said that, I would like to, and people who are already in West Coast, probably, by that time we finish, it will be 8:30 or around 8:30. If you don't want to watch it tonight, but definitely tomorrow is Sunday, you have to watch this movie. This is the mandatory. I really want all of you to watch. It's a free watching. You don't need to pay any money, anything. Just watch, and preferably watch with your kids. Okay, even they're little kids, but they'll understand. You have to bring that innovation culture. It's absolutely marvelous. Okay, movie. Whenever I get a little depressed, I just watch this movie. There are other movies also I'll suggest, but just watch this. So having said that, let me uh, share my screen, and I'll play first 3 or 4 minutes of the movie, and that's about it. And then I'll place the this thing, what do you call, the link on the chat, and then you can watch it anytime.
June 1957, at San Francisco's luxurious Cliff Hotel, 8 of the country's most talented young scientists and engineers assembled for a secret meeting. For the previous 14 months, they'd been working together at Shockley Semiconductor Laboratory outside of Palo Alto, developing a technology that promised to be revolutionary. But in recent months, William Shockley, the head of the company and the mind behind that technology, had become increasingly erratic. Now, the 8 were conspiring to defect, to quit Shockley and form their own firm, under the leadership of one of their own, 29-year-old Robert Noyce, a Midwesterner with a brilliant scientific mind and the genuine affability of a born salesman. It had taken some convincing to get Noyce on board.
Noyce had a young family, and to leave sort of a known paycheck for something that there was no model for, this notion of breaking away and doing something different.
Soon it came time to seal the deal. In the absence of an official contract, 8 newly minted dollar bills were passed around the table for signatures. Noyce got out his name.
I honestly think that Silicon Valley begins on a very specific morning. That morning is the morning that the guys from Shockley don't know if Noyce is going to go. And he gets in the car that morning and goes with them.
Those dollar bills they signed are Silicon Valley's Declaration of Independence, a statement that we are going to go out and start a company according to our own ideals and our own beliefs, and nothing's going to stop us.
On that morning in 1957, none of the 8 defectors likely had any idea what would happen next. The coining of the phrase Silicon Valley was more than 10 years in the future. The unique business culture with which the place would come to be associated, openness over hierarchy, risk over stability, innovation over the tried and true, had still to be tested. And the integrated circuit, the revolutionary technology that would usher in a new era in human history, had yet to be invented. That morning, the future Silicon Valley was just a speck on the map, and a most unexpected place for the information age to begin. Had it not been for William Shockley, everything that was to come might well have happened somewhere else.
All right, so I'm going to paste this link on the chat, this thing, and then we'll get started. I don't want to waste time on this, but it's a beautiful, beautiful documentary. It's not a movie, basically, it's a documentary. Okay, so hold on. Okay, so everybody must watch this documentary. It's a must. Of course, I'll also put it on the Discord server. People who have not joined the Discord server, I'll put the instruction on the during the break, and then please join the Discord server. Today is our trainee. He has an exam, so he's not there. That's okay. So so please, this is your because in India it's Sunday everywhere except where it's Saturday evening. You can this weekend just watch this. So welcome to Silicon Valley. It's a wonderful, wonderful place. It's best of the best place on earth in terms of innovation. So what that William Shockley started in what was the year that was in 1957 or something, more than 100 times bigger is coming. They started with transistors and the chip revolution and how everything started, how the semiconductor industry started. wonderful, wonderful, all those, people you can see, Bob Noyce, Ted Hoffman, Andy Grove, they're the people who really built this, the whole thing, this whole computer revolution or digital revolution. But whatever they did, it's really remarkable. Now, that really put human civilization, I would say, at least 100 years ahead, those 15 or 20 years. Now, this is what is going to happen. What is going to happen is, as per Ray Kurzweil, I'll share all those videos with you, and I created a lot of videos on that. He says, and I have every reason to believe what he said, that for next 100 years, okay, human, the world will progress for next 20,000 years. That means the world will witness the 20,000 years of progress in next 100 years. That's for sure. I do believe. I have every reason to believe. Now, when you are talking about that, then there is another concept came, then okay, that's fine. So what will happen? Because a lot of people are in their 50s, a lot of people are there in their 60s. Are they going to witness that kind of a progress? I said yes. Why? And there is another theory, and you can do it, because in 20 years the medical knowledge will be so much advanced, the average lifespan of people will extend to 150 years. Okay, that's for sure. Unless you do like some kind of stupid stuff, smoking and never quit smoking and drugs and all, people will not even die for in accident, because entire world will see there will be self-driving car, and when there is a self-driving car, there won't be any accident, because there won't be any crazy driver, drunk driver. It will be all driven by software, beautifully managed or coordinated. It will all those cars will never speed up, never do all kinds of a crazy turn, and there won't be any accident. So people will not die of accident. Yes, people will die of something like a deadly disease, like a cancer. Of course, there will be cure for that, but still there would be some crazy stuff going on. So this is the excitement part of the human civilization. We are living it. We are really living it. You are going to witness it. That's the excitement part. Now, having said that, so we are talking about the master algorithm. On my first day, I talked about singularity, and if I can find something, basically, okay, give me a second, because I have to find that slide, but I'll show it to you. Just give me a second. I'll stop sharing. I'll have to find that slide, and I'll show you, and then we'll begin. Okay, so meanwhile, I'll be talking about it. If you can ask any question if you want. So otherwise, I'll have to find that slides where it is. Just give me a second, okay? So, uh, I don't know. Anybody wants to talk about anything about that? Because I'm trying to find that slides. Just give me a second. Okay, I don't know where it is. Okay. And you can unmute yourself and talk while I'm I'll have to give, because I'm just trying to find the slides, because that's otherwise if I don't show you the slide for some reason it's my fault, and I'm just trying to get this slide. Just a second, as soon as possible. Okay, let me see.
Amit, quick question.
Yeah.
How much programming and coding knowledge would we have to know to take part in this innovation that's happening in the AI space?
Good question. Basically, yes, there are two. Basically, there are two, because we are running two track basically. Okay, one is track for basically like I found this. Okay, thank you. Okay, very good. All right. So let me first just a second. Let me share the screen, and I'll. So basically, we are doing two track. One is for people who don't want to get into all the technical stuff, but they want to part of the AI whole thing. They can fill the track of a management kind of a role where they can really do like a high end architecture role, which is we are going on parallelly, and from next week it will be really go on. And people who really want to get into the AI kind of stuff, like really AI innovation or all, for them, we have a planning. So lots of engineering, mathematical background, and also the programming background required. Because AI is hard, and among because I come from engineering background, okay, I can tell you, and I have pretty much idea about other engineering branches. Among all the engineering branches, AI, the innovative kind of AI, not like what you see like a prompt engineer, that's really hard. Because why it is hard, I'll let you know once I complete the presentation. You'll know what it is. But it's a good mathematical foundation required, good programming foundation required, good engineering, reasoning engineering, critical thinking required. And so I already covered this on our first, I think the second day of the first week. So you'll get to watch that video. It's called Think Like Wright Brothers. But the good news is, if somebody joins, it doesn't matter the person is a college student, or probably is looking for his career change in his 40s or 50s, 60s, doesn't matter. We don't care about age. As long as the person is willing to learn, and we have a complete curriculum, because we just started teaching all the Python and all the programming, but we will never end. It will be always go ongoing process, and people will come and join us wherever they want, whichever the way they want, and they will learn, because we are building an ecosystem of learner all over the world. So most of the, we are not going to spoon feed, that's for sure, but we are going to give you lots of like this kind of a workshop, like soon after we complete this workshop. There is a team among us who are from Microsoft. They're all Microsoft engineers, so they are going to start all those Azure kind of a stuff with AI and all. And then another, so it will be ongoing all the time. So keep on, join our Discord server, learn as much as you can. We'll have our own video channel, podcast, our own GitHub, every little thing, whatever you need to learn, we'll give you, but we won't spoon feed you. And in that process, some people, because they have the mathematical background, programming background, they can really, but they are doing something else, they can really catch up, or they can really be with us. Probably in 3 months they'll be ready to really start with us. Or probably some people don't have any other background at all, so they need to work a little hard, depends on how much time they put in. And then they can they'll eventually be at part with other guys. It might take 3 months, 6 months, 1 year. It depends on all individual, how much that person really puts effort. Some people can put like a 10 hours effort, some people can put total like a lots of effort. I learned that way. I mean, AI is a brand new field, although I've been working it for a while. And I was really having my own consulting business and other business. But that's like I said, okay, if I have to learn AI, I'll have to devote full time. So for me, 80 hours a week is a norm. Even today, I put in 80 hours easily, 13, 14 hours a day easily. So if people have that kind of a dedication, even they have a full-time job, they can learn. And if people who say, no, it's okay, let me watch this movie, let me look at other stuff, there is other party going on, I need to go there and spend like a 5 hours a week, so their progress will be slow. It's all individual. But yes, there's whole lot of things need to be learned in order to get into the technical track, on the managerial track, or the architectural track. The technical maths or programming may not be there, but there will be still a whole lot of things to learn. It's on the individual. Make sense?
Yes, thank you, Amit.
Okay, all right. So let's get started. And as I said, I'm going to get started. And today, because we start a little late, we are waiting for others and we are going to cover lots of stuff. So I have to extend it to at least 15-20 minutes. So bear with us. It's mostly Sunday morning in India. You can find people who are in California, in East Coast and other, probably it will be a little late, but 15-20 minutes okay, because we are going to learn a lot of stuff. So this is the roadmap for artificial general intelligence. You can see this. There is some site called, it's not my this thing that I got it from AISOMA. I don't know what is that. Some organization, something, but I found it. I think somebody gave it to me or whatever. I don't know what. So yeah, this is some kind of a German. .d means it's in Germany. So they created, this is a beautiful thing that I always put it. I don't know if I'm violating their copyright law. Hey, I'm sorry for that. I'm giving you credit that this is from AISOMA.de. So I'm giving you credit. And so, this is for learning. We're using, we're not stealing any of your stuff. Disclaimer. So if you're watching, or your lawyer is watching from somewhere, this is our disclaimer. Okay. This is all learning stuff. Anyway, this is a beautiful slide. So you can see this. This is the roadmap of AI. And the master algorithm is the fifth state. And I'll tell you why. So what happened is, now you can see this from now, it's a weak AI. The computer can simulate the cognitive process in a non-human brain, but state that the machinery may or may not relate to those in non-human brain. So basically, computer, everybody thinks artificial intelligence, that means the computer can think like a human. Not yet, sir. And when I complete my presentation, you'll know why. Okay, so that is the very important part of it. So what happens is, so if it cannot really, so this is the weak AI, means it is doing fabulous kind of a work, generative AI, and you can see this is creating images, it's creating videos, it's creating fake videos, deep fake. You see, it's everywhere. People go, oh my God, this is the AI stuff doing it, and then it's writing programs for you, it's writing essay for you, it's writing all kinds of a paper for you. It's humongous, power, but it's not yet intelligent because it doesn't think like a human. So that's a weak AI. But because of the advent of cloud computing, because you can use enormous amount of computing power, unlimited amount of computing power and storage, so all your logic you can really run on a very, very large scale. When you run your logic on a large scale, it can do enormous amount of stuff. Okay, so we have not seen even the 1% of the real capabilities of AI. We are going there, but not yet. Okay, then this will go on till the 25th, and then from 2025 to 2040, a strong AI, non-human, is still non-human. It still does not think like a human, and I'll tell you why. You'll understand. You'll relate it. Just have that thought in that. But it's so powerful that, come on, man, we are not that powerful. That AI is doing so much thing, and humans are not that powerful. How can it's not? It's like a dumber than human. Okay, I'll tell you why. The cognitive states found in machines are not functionally identical to the brain, and therefore cannot be used to recreate the human thought process. Why human thought process cannot be used? I'll tell you. You'll understand at the end of the presentation. Then this is called singularity. The strong human AI. This is 2040. Some people say it might come earlier than that. And Ray Kurzweil of the Google says it's going to happen in 2045. Given with all the war and all kinds of crazy things going on in the world, I might give it to another 5 years. So by 2050, it's definitely going to happen. So what will happen is your AI is going to think like humans. Okay. And when it thinks like a human, but it will be as intelligent as human. But think of it, if you combine all the intelligence of all the people on earth, how many people are there? 8 billion people. Okay. And if you combine all their intelligence and put it into one brain and you create that brain, this singularity will be more powerful than that brain. Okay, so that's called master algorithm, and it's dangerous also because earlier on our first part we played the video of Dr. Jeffrey Hinton, who says this is an existential threat because AI can destroy us, kill us. Okay, so that's what the heading. It may not happen. Humans are always smart, they will figure it out to not to get into that kind of stuff, but there is a danger if it is really not used properly. Okay, properly means it's not a nuke, like everybody has a nuke and then there's a deterrent so that nobody attack each other like Russia, US, China, India, all those countries. But here it's not nuke, is more dangerous than nuke because AI is such a thing nobody can control. It's already there. All those network, all those social media network, all those cloud computing network is already there. No one person can switch on and switch off the button, just like a nuke. But when it goes out of the control, it might destroy the humanity, literally. So that's another topic, but I just wanted to do it. So let's be positive that that's not going to happen. Humans are smart, they will do something so that it is tamed forever, it is controlled forever, so that it never goes out of hand. Or whatever you watch in science fiction movies and all those science fiction novel, that doomsday scenario that AI takes over and destroys the world, it's really is going to happen. As per Dr. Jeffrey Hinton, who is the godfather of AI. So I already played that kind of a video. He already said it to CNN and all those news channels. So you can go and search for Dr. Jeffrey Hinton's on the YouTube. He's there. You can watch it. So this is the. So when I come to this, it's called master algorithm. That's what we call master algorithm. There's a book also on the master algorithm, and there's a whole lot of things there. So today, last time we talked about the master algorithm, how it's going to happen. Give me a second, I'm going to take another slides, and then today we are going to conclude the second part of the master algorithm, and we'll get started. Just a second. Just a second. Okay, yes. All right, so so basically, you can say this. I will show, because last time what we covered, I really want to. A lot of people just joined today, just first time, and they may not be able to relate what we covered last time. So I would like to go over like a recap kind of a stuff. Last time what we covered, and so that you can relate what we covered, and then we'll go into the main presentation of today. So this is a recap of last time. So I won't go. I'll just go through the slides and tell you what we covered. Okay. Okay. So this is the first lecture of the master algorithm. So we covered about how the computer logic work, how everything work, and what are the different algorithms that are available. So basically, what you're saying is, what is the master algorithm? Master algorithm means there would be one algorithm, because if you go to people who are already into AI space and people who are not, at least they have some idea that AI is nothing but a computer algorithm. Computer algorithm, like it's a set of instruction. Any computer programming it knows what is algorithm. It's like a set of instruction. Okay. And in that set of instruction, you give some instruction to the computer, and the computer processes. That's algorithm, plain and simple. Now, AI also runs, because AI is what? It's basically a set of instruction. You give it to the computer, but at the same time with that set of instruction, so there's a difference between programming and machine learning. If you are not familiar with machine learning is you are giving some kind of an instruction to the machine. It could be your laptop, it could be a server, or it could be some kind of a robots, or it could be some kind of IoT, anything. So when the machine learns from some pattern, basically that's called machine learning. Why it learns from pattern? Actually, if you look at our learning, human learning, we just learn from pattern. Okay, if you talk about the child, 3 4 year old child, the child learns about the about dog, cat, and everything based on the pattern the child observed. Sound, noise, it's all pattern. Even in it, any kind of a data, you can really go inside the data, you can learn some pattern, you can learn some trends. And so how you do that? So the programming only does the whatever it does to for the instruction. Now with the programming, you create a mathematical model, uh, and then instruct through programming to the machine. Okay, based on this mathematical model, you learn the pattern of the data we are going to show it to you, and based on whatever the data the machine sees, and then learns the pattern based on the mathematical model. It's whole lot of mathematics. Today's presentation was full of mathematics, and then I said, "Oh no. A lot of technical people say, oh my God, I'm not here. They won't come here." So I took out all the mathematical stuffs. So, but one or two little simple one I'll discuss. So basically, so those patterns, when the machine learns, okay, that's called machine learning. Okay, so programming is just simple instruction, it doesn't learn anything. But when you ask the machine to learn some patterns in the data, and that is machine learning. So that's about it. So when the machine learning learns some data, basically it's learned through some algorithm. Okay, what those algorithms are, some kind of a mathematical model it creates, and then some computer instruction is done. Now if you look at the algorithm, there are hundreds of different kind of algorithm, many algorithm. Okay, all those algorithm work, all those. If you go to Amazon, you see it shopping, you see all kinds of recommendation engine, face detection, your Facebook. If you go to Facebook, it will connect you with all kinds of algorithm to really keep you the network. So all those kind of algorithms are out there. They're working in a different way. They're working in tandem. They're working in collaboration. So many things are happening. Now if I say that, then somebody says, okay, fine. All the scientists say, why so many algorithms there? Why there should be a master algorithm, only one? Okay, because, and that's what I'm coming to the human brain, because why human brains are superior than the computer, although computers are huge powerful, they can do calculation in seconds versus, suppose if you want to count from 1 to 100, and if you add, like a 1 to 100, 1 plus 2 plus 3, it will take you, even if the best mathematician, at least 2 3 minutes to add it. Computer will do in less than a second if you have the right program running on. So although it can do lots of stuff in second, what you humans usually do in days or weeks or months, but still it is not intelligent enough. I tell you why. Because it uses different algorithm for different things. But our human brain has only one algorithm. Only one algorithm. That's the master algorithm. We see, we hear, we do all kinds of things with only one brain, and there's some kind of lots of different algorithms are there. They're working, but they're working with some kind of a control mechanism. Some boss is there inside our head, and that boss is telling us how to learn a guitar, and then how to go and learn swimming, and that same algorithm is teaching us how to learn AI. The same algorithm is with that same algorithm, we can do anything. Basically, you can do all our ordinary work, our office work, and also we can learn anything from mountaineering, mount climbing, to how to fly a aircraft, to swimming, music lesson. You need, name it. We don't have different algorithm in that. It's one algorithm, but there could be a different varieties of that. So master algorithm is something. So there could be lots of different algorithm to learn different skills. But inside our head, there is something there that controls everything, and we don't know because it's natural for us. Okay, so but scientists figure it out that, hey, that's what the human brain works basically. So how we can simulate like a human brain, so the machine thinks like a one algorithm, just like a human brain. The same algorithm will be used for doing some kind of stock market calculation. The same algorithm will be doing for some kind of a e-commerce, for recommended engine. The same algorithm will be doing for some kind of a face detection problem, catching the terrorist, security, you name it. But it's all different. So that's the master algorithm we are talking about. So basically, I'll skip this part. So this is what we covered last time. So, but I'm not going to. This is recorded. You will be able to watch it. But what I'm saying is, so I'll come here. I'll just come to the point. So there are five tribes of machine learning. So I will extend this idea to the master algorithm in the second part, which is the concluding part today. So basically, this is symbolist. Symbolists believe that all intelligence can be broken down into manipulating symbols, like mathematical symbols, which is really the idea. So basically, the symbolist. And then there is something called connectionist. These are the different tribes of machine learning, different school of thoughts, and all of them work basically. None of them is not like a dumb idea. And then under that typical tribe, there could be many algorithms are working, but this is the different way approach, a different school of thoughts, I would say that. So the connectionist believe in reverse engineering the brain's learning process. This is what I was talking about. We'll talk about back propagation today. You'll understand the perceptrons and everything. Dr. Jeffrey Hinton, I just spoke about him. He is connectionist. Okay, so neural network will be talking about this. And there's something called evolutionaries. Evolutionaries is like you learn through evolution basically. You drive in learning, just like a Charles Darwin kind of a thing. We'll cover that also today. Okay, genetic algorithm in optimization problem, those kind of stuff. I just wanted. Then there's something called Bayesian. Bayesian, if you are have a mathematical and statistics background, probably if you have never learned Bayesian, you failed your subject. If you want to pass statistics or get a good marks, Bayesian, you just master this particular stuff, and others will be so easy. Trust me. Okay, so Bayesian is a very mathematical as well as statistical tools for inference, as a likelihood of email spam and all those things. Different kind of a statistical tool. That's also kind of another tribe of algorithm. And then we'll also cover this. So remember all those things. So please note it down, because I'll be covering today, so you will understand. At least I will give you some idea. And then analogizer emphasis recognizing similarity between situation to make inference. I'll be talking about that. The infer similarities based on how similar two situations are. Recommendation system like Netflix, Spotify. So if you like one particular movie, and then it says, because probably you have some, and then it analyzes, and then some kind of analyzers it has inbuilt in the Netflix system to see this particular movie you like, and then from there it say how many people those kind of a particular movie like, and some kind of an analogy it derives, and those kind of stuff. Okay, So each tribe offers unique approach to machine learning, and researchers often combine ideas from multiple tribes to develop more powerful learning algorithms. Okay, so this is the last week. Little bit of recap. I don't want to go into last week itself is a more than 2 hours of lecture, but at least the gist of is the main theme I covered last week. These are the 5 tribes of machine learning, which we are going to extend today. So people who have not attended last week workshop uh, should not feel like, okay, I don't know what's going on. He's talking about all those things. Never heard of this. At least this is the extension. This week is the extension of this 5 tribes of algorithms. So at least you understood what it is. So remember, we'll write it down. Symbol is, I'll be talking about this again and again. Symbol is, connection is, write it down. Evolutionaries, please write it down. Just write down the name, then I'll explain it to you as I go. Then Bayesians and analogizer. Okay, so please write it down. Symbolist, connectionist, evolutionaries, Bayesian, and analogizer. All of this I'm going to discuss again in length, in detail. Okay, then you will come to the conclusion how master algorithm can be developed or will be developed, or whether it can really be developed. There's also a question there. Okay, so that is something interesting we are going to talk about. All right, make sense? All right, so that's about it. You don't need, I don't need this. Okay, so you got this idea, so I'm not also going to show you this. Now come to our main this thing. Okay, so this is a master algorithm. So basically, now here in the first slide itself, it says connectionism. You talk about connectionism. Okay, and you remember I talk about Dr. Jeffrey Hinton, the connectionism, and he's one of those, proponent of the connectionism. Neurons fired together, wired together. So Hebb's rule is the principle of neuron science. And what he says in 1949, he came up with, because he's like a neuroscientist guy. So basically now, why we are trying to understand neuroscience, because we are trying to really copy the human brain's algorithm into the machine and make it like a 1 billion times more powerful than average human brain. So in order to do that, first you have to really understand how the brain functions. So you'll have to go back to the neurons and how those neurons, the perception came into, and how those deep learning is really working today. All those generative AI you are doing, all those large language model you are seeing, all those deep fake, all those generating images, fake, all those things because of the deep learning. And deep learning is based on this neural network connection. I'll cover that, you'll know. So this dude Hebb said that Hebb's rule state that when two neurons are activated simultaneously, the connection between them strengthen. So this says that this is that neurons that frequently fire together develop the stronger synaptic connection. It will really not make sense unless I'll show it to you what it is. Basically, so all the neurons in the brain there, and then when they're connected together, it fires, it gives you a signal. That's the way we learn, we remember, that's the kind of that is the way humans have intelligence. So that's a Hebb's rule. So and then how this Hebb's rule is converted into some kind of a logic here. So basically, you see this Hebb's rule has application in various fields, including artificial network. It provides insight into how experience shape brain. So you have a neuron A, and there is a synapse. The next, there's some kind of a connection between neuron A and neuron B. Some kind of a nerve or something, some kind of a connection there, and then that cells that fire together wire together, and then all the signal coming to neuron A and neuron B, that gets accumulated. There's something called activation. It gets activated, and then it fires. It makes sense to us. It creates the intelligence. we watch, you are watching. So a lot of our eyes is glued to the screen, and our eyes has a lot of neurons, and then all those what you call the lens and everything inside the eyes. I'm not a biology guy, so I don't understand all those stuff. But what I understood that all those neurons connected with the eyes, it goes to the brain, and then it whatever we see, we look at it, and all those signals is some kind of electric signal that goes from the eyes to the brain, and then it processes, and all those things happen through the neurons. And all those neurons, and there are millions of millions of billions of neurons. Only the neurons that are active for this eyes and all the vision related function, they're the one who are really active now. So they fire together and process, send some kind of a signal to the brain wherever it is, and it happens. So I'm saying it, I'm hearing it, but I'm not eating anything, I'm not drinking anything. So our neurons in the tongue and my taste area, they're inactive now, they're not active. I'm talking now, probably my speech and all those neurons are active. I'm hearing, my neurons are active related to that. I'm seeing it, my neurons, but there are other neurons that has so many other functions which I'm not doing. So they are inactive. So that kind of a connectivity says that. So simulation activation strengthens synaptic connections. Okay, now, so in symbolic learning, there is one cornerstone between symbols. We remember we talk about symbolic learning when it sees all kinds of basically mathematical equation and function stuff like that. The concept they represent in contrast connectionist and representation of distributed. Each concept is represented by many neurons. So this is all biological stuff. Okay, the main limitation of computers compared to brains is energy consumption. Okay, your brain uses only about as much power as a small light bulb, while Watson supply could light up the whole of his building. So IBM Watson, even IBM Watson consume lots of power. And so artificial intelligence is good, but environmentally it may not be good, because this consume all the cloud computing, all the computing processes, or the computing power it needs, or the storage power, storage it needs, it requires power. Human brains needs a little bit of power, just to. So because it's a biological function, inside how the biological stuff work, I don't know. But for the sake of it needs little power versus the Watson, which is not as smart as human brain, the IBM Watson, that defeated chess champion and all those things. It's everybody what is Watson. Even that smart machine is not as powerful in terms of smartness like human brain, and use like at least million times much power than what our normal human brain uses. So that's another thing. So this is the slide I would like to stay with. So basically, and this is what I understood about biology, to be honest with you. I'm not a biology guy at all. So I don't know. But what I understood and how I can really relate to this deep learning, being a deep learning, practitioner, I can say that. So basically in the biology, so basically there is something called dendrite, there is called neuron, and there's something called axion. So what happened is this dendrite is some kind of it's like some kind of a sensor. It gets all the signal from different like eyes or ear or whatever, and then this is basically nucleus, and then through there, and this is like some kind of a pipeline. So it through the pipeline it's called axion, and then it goes to the signal, and then it processes in the brain. So these all the signals are coming together, and then it coming together, and then it processes. So it's all activate function. So in the deep learning there's something called activation function. So it's not like it gets one little signal, tiny signal, and it immediately sends it to the brain. It doesn't make sense. It will never make sense. If I'm looking at the screen, I am looking at the broad everything about the screen, what is written on the screen, I'm learning it. So all those signals, all those visual signals are coming through my eyes to the brain to one place, and that one place accommodates everything. It just stores everything. It doesn't send one by one signal. It puts everything together, and that's what called neurons, which are fired together, are connected together. It's all connected together. It goes into the brain where it really processes, understand, oh, I'm looking at a screen, and the screen has some kind of a diagram showing how the human brains work. Then there is the equivalent of the deep learning network is work. So this is all the processing, all the signals are fired together. It's not like a one after another coming, like a as soon as it is getting the signal, it is sending. No, then it doesn't make sense, because those need to be assembled somewhere so that we get the whole picture. So that's what I understood about the biology. Okay, don't ask me anything more than that. Okay, but that is now. So what happened is here in the deep learning. So deep learning, you see so the model learns a pattern. So this is called perceptrons, a basic building block of neural network. They are single layer neural network that consist of input node, weights, and summation function and activation function. Similarly, so what happened is all this, I'll give you an example, and this is very important. This is the concept of deep learning. We'll have a separate deep learning, hands-on deep learning course. So even if you do not want to get into the technical stuff, there will be a lot of non-technical, without coding kind of things I'll be explaining. So please do attend that. So there, basically what happened is, all the, suppose it's an image, and it's an image of a cat or a dog. So that image is broken into some kind of a pixel, and those pixels is broken into number, and then it, when it sees it learns the pattern, and then it gives you the output. And similarly, like it's all the words and all the signals, all the different combination of number is gathered together, and there's something called activation function is used programmatically, and then it fires it gives the output, and the output you can see that, okay, the machine saw a cat, the machine saw a dog. So that kind of output it that get, or it could be a binary output like a stock option, or whether it will rain today or not, based on whatever the data the algorithm says. So that's kind of a thing. This is the so same stuff basically. The perceptron basically gathers all the signals and then wait for some time when everything is accumulated. Then it fires, and then through action it goes to the brain, and brain processes. Similarly, it gets all the linear functions and everything, and then there is something called activation function, which is a mathematical function basically, that uses it, and then it just fires it, and then it processes, the output gets it. So this is the this thing. So while perceptrons can only learn linearly, separately, so you understood the whole thing. I will come to this another slide. Hold on just a second. So basically, this is not today's lecture, but I wanted to show you to you how there's something called neural network. This will be our part of the deep learning lecture. This is highly technical, by the way, but I'll explain it to you. So you see this, it gets all the signals, and there's something called weight. I'll tell you, weight is some kind of arbitrary number. I'll tell you what it is, just for the remember. For today, it's weight, and it gets all the weight, and you see this, there's a summation, basically. Oh my god, there's some kind of a summation here, so it gets accumulated. You see this, there's a summation notation, and then it gets it, then that's called activation function. So you see this, and then it adjusts the weight, and then if there is a you want to find a relationship between students in a college, how much they are sleeping versus how much they are studying, and what is the final grade. Of course, if they sleep more and study less, they're going to fail or probably get lower grade. So that kind of a pattern it learns from the data. And but how those pattern it learns, so this is some kind of a activation function it does. Don't worry about all those nitty gritty. Just think of it like all the signals, all those data, all those pattern it learns, and those patterns is coming through different kind of a mathematical way, and then there's something called activation function. It fires it, and then it gives you a binary answer. There could be a linear or binary answer, or there could be non-linear function. I'm not going to get into all the details now. Okay, so now let's go back to our basically I am because we started about 15-20 minutes late. So if you want, I can give you a break now, or if you want to go on, you can go. I can go on. Whatever you do, I would like to give it go on for another 4-5 minutes, and then give you a 7 minutes break. Go and have your coffee or whatever you want, and then come back. We continue a whole lot of things to cover today. Okay, so there is something called Boltzmann machine, has a mix of sensory and hidden neurons. So these are all Boltzmann machine is also some kind of a sensory and hidden neurons. You can see this. This is the data input, and this is the learning process. These are all come from the biological and neurology and cognitive science. So basically, what the scientists started doing when say, hey, we need to create artificial intelligence. So I said, okay, first of all, say what is intelligence? Define, and then it's a define what is intelligence. Then we'll have to find what goes inside our brain. As a matter of any animal, every animal has some degree of intelligence. And dog, very smart dog, has some kind of intelligence of 3 or 4 year old, a child. May not speak or something, do handwriting or something, but that kind of a intelligence it has. That's why some dogs are so smart, police dogs and everybody. So that kind of intelligence, how the animals, especially humans, had that kind of intelligence. How would that intelligence happen? So let's study the biology, let's study the neurons, let's talk to some expert who are doing research on how the brain works and neurons and all those things. So but actually, this Dr. Jeffrey Hinton, who is the godfather of AI, he's a basically a psychologist. So he understood the cognitive function. He's a doctorate in psychology, but also he did his another PhD, I guess, in computer science. But he mixed that field because his actual background is psychology, and then he learned computer programming and mathematical and all those things, and then he can relate because he understands the psychology better than us, because we are all engineers. We never even read that psychology. A lot of people, even I used to had a hard time spelling the psychology, let alone learning it. Okay, even today, he asked me, I'll have to think, then I really spell it properly. Admit it, because we are not from that field. But he came from that field, and he also learned computer science and all the computer language. It's a very famous scientist, basically. He should be given a turning. Oh, he got the turning award. Yeah, it's like a equivalent of Nobel Prize in the computer science. So then he learned the process, the machine process, then visible, there's a visible layer, there's a hidden layer, the hidden layer. So this is all Boltzmann machine. Don't worry, these are all different layers in perceptors and all those kind of things. I'm not going to get into details. You saw that diagram. This is very complex. We'll cover that in a deep learning session. So now this is the, if you want to really, okay, let's take a break, because this is something very interesting I would like to talk to you. So let's take a break, and we'll take a break for 7 minutes. We come back, and we might go a little bit extra time today because we started late and a lot of things to cover. So we'll take a break for 7 minutes, and we'll come back and continue. Okay. So that's about it. Okay. So basically, I started a timer here, like as usual. So, and I don't know if you guys can see the screen. So the timer just started. Let's take a break for 7 minutes. So actually, okay, okay. So and then we'll come back. And
Dada, you are on mute.
going to unmute myself. All right, everybody can hear me now? There's somebody asked something, I don't know what.
Yes.
Okay. All right. Okay. So let's get started. I don't know everybody has come back. I hope so. Can I get one or two here? Like okay, we can get started. I don't know. People are started coming.
Yeah, we should start.
Okay. All right. Okay. Yes. Okay. All right. Okay. I think people started coming. Good. All right. So I guess everybody can see the screen. Okay. Now, if you really want to understand life, this is the card you really want to understand. This is the most famous card in the world. All kinds of from life situation to engineering to everything to marketing. This goes by one card called S card. Okay. Giving an example about life. We born, then we just get educated, and then we grow up, we get college degree, and then we some kind of a job with it, we grow, and then we are growing old, and then we are also doing some, and then it goes to a level, and then slowly it goes to some kind of a saturation point, and then it declines and start again. So this is called sigmoid curve. Sigmoid function is a very important function, very important function in deep learning. But if you look at the card, I don't know if you can see it, it's actually it's saying the non-linear card. But if you expand this linear, I'm just trying to expand the screen, it won't happen. But if you see this, if you really magnifying it, actually it's a linear this thing, because it's a straight line, it's not a curved line. Every little point, that's the beauty about the signal curve. So basically the human brain exhibits a scarred pattern in various aspects of cognition and behavior. Mood swing, it really goes into the basically your S curve kind of trajectory. Your mood is up, on, off. Mood swing is a very good example. Then children learning, and also I would say the adult learning also can be understood as an accumulation of S curve rather than progressing steadily. Learning tends to occur in burst of growth followed by a period of consolidation. Each new skill or concept learned represent an a mini S, maximum, minimum, those kind of mini S curve. And starting with a slow acquisition, accelerating, and then understanding that depends, and then basically you can get into the mastery kind of thing. The S curve nature of learning highlights the importance of patience and persistence, as progress may not always be linear. So it's the progress is not always linear. It's like a curve, like it's like a haircut. So understand the S curve pattern in the brain. So brain also, we also learn not all our mood swing, our emotion, our the way we learn. Basically, it's a S curve basically. So it's like a goes through that S curve, like a rise and come, and then come to some kind of a 0 point, and then it again goes up, that kind of stuff. So now why it is so important? Because first you will have to understand, when you are asking machine to learn something, and then you are asking machine to, you are really trying to give that human intelligence, or instill or embed rather a human intelligence inside a machine or algorithm. You have to understand how the all kinds of different way we learn, humans learn. And S curve is a very this thing, and there's something called sigmoid function. When you use it in a deep learning, we'll use it on our deep learning curve. Then it will make sense. So that is very important. So basically, what we had the master algorithm is what? There are all kinds of algorithms. I just showed it to you, but those are not human algorithms. Now we would like to create one algorithm that will think like human. May not be as million times powerful like human, but it will have like a those kind of a thinking process like human. Okay, much powerful. So that's the master algorithm. So there is something called back propagation. I already talked in the master algorithm concept. So basically, you have the input layer, you have the forward propagation, you have the update weights, the hidden layer. So what will happen is I'll give you another. Let me if I use these slides. Okay, so you can see this. This is basically a back propagation. The back propagation is, I don't know how I'm going to explain it in a very simple way. It's hard. Back propagation is all the signals you are looking at and you're comparing. So if there's a picture of a dog or a cat, and then the machine sees 1,000 picture of a dog, 1,000 picture of a cat, it sees a pattern, and then it relates that pattern. So that pattern, learning pattern, you have to really some kind of a, so there is something called input layer. So I won't go. There's something called input layer. So these are all input layer into the first picture, and then it goes through some kind of a weight. As I said, that don't worry about that. There's some activation function, and then you get to the output layer. But every little neuron is just like act like a neuron. So it's like a one pixel divided into several combination of number. I'll get into that, and those pixels, and there will be for one particular say something like a 200 by 200 pixel, some kind of a picture. It has so many pixels and then multiplied and all converted into number, and it learns the pattern, and then it learns the pattern, and then so there is something called, so basically what happened is the output is is called y hat minus y. So what is the input output layer? And then so this is something I'll explain it to you on this mathematical. Let's not get into that. So this kind of happen is, so what happen is, so basically you have the combination of layer. You have the input layer, all the inputs are coming, and then from that input layer you're detecting a picture, and you want to detect it whether that particular picture is a picture of a dog or cat. So how you are going to do that? First you learn all the pictures from the 10,000 picture of dog, 10,000 picture of cat, learn the pattern in terms of pixel and combination of number, and then you give the output and compare the output with your input. And so there is always a difference. There is always a error, because output on the first iteration, it will not give you the right error, this thing, it will give you some error, and then you minimize the error by you introducing some kind of a weight, and that formula is the summation of y hat minus y square, or half of that. So there's a mathematical concept, but I'll tell you, give you a very easy example how this works. So you have a, so suppose you have a scale, and you have a you picked up a piece of rock from somewhere. You want to weight it. You don't know its weight. You show it. It could be some kind of a 2 pound or 2 kilogram. Let me say, because a lot of international people, they don't understand the pound concept here we have. So you have a 2 kilogram of you thought, this could be 2 kg. So put it on a scale. The scale goes down, and then you put a this thing 2 kilogram of weight on the other side, and the scale goes up. So what you do is, oh my god, this is this that means it's not heavy, and it's lighter than 2 kilo. So you put another, take out, you put like a 1 kilogram of weight plus another 500, you guess is like a, now it should be between 1 kilogram and 1.5 kilogram and 2 kilogram. And then you do that, and then it tilted little bit. You said, oh, now this is heavier, 1.5 kilogram is heavier, but it's definitely less than the 2 kilogram. So you change the weight, and when you change the weight, basically you adjust the weight and you go so deeper. Then one point of time, you might find that actually the weight of the rock is 1.6259 kilogram. If you have that kind of a small weight, you have those. So now you understood that you are adjusting the weight and you are getting the right. Similar concept, that's what it's called weight. So you adjust some kind of a right number with the input neurons. So basically, and then you, the difference between what your output and what is your input, your output and input should be same. Then only say it's a cat or dog, right? So that kind of a thing. So you have to do it back propagation. So just like you are adjusting the weight to weigh a piece of rock, similar kind of a things you are doing mathematically. Makes sense? So that is what's called propagation. I'm not going to go into all those details. And then I'll tell you this mathematically. So you understood what is back propagation, right? Now there is if you this is a calculus. People who have basically have the knowledge about calculus. This is a three-dimensional view of the calculus. So all those neurons, so all those pixels, they represent each neuron kind of a stuff. So think of it, all those pixels represent each neuron. To each neurons, you have to add backward, because you know what, whatever the output you are getting, and input is different than output. Similarly, think of it, your piece of rock weighs something, you are getting, you put the output like a 2 kilogram, but actually it's a somewhere between 1.5 kilogram and 2 kilogram. You adjust the weight, but you adjust the weight, that's a one piece of rock. But it's suppose if you have like a 10 piece of rock, you are adjusting together. So you have to adjust the weight, and both all weigh different. So you have to weight that. So mathematically with calculus, you'll have to find the local minima, not the global minima, because it's all on a same scale. And then if you do the calculus, you know the rate of changing is the differential calculus. Basically, when the slope you covered, so in the differential calculus, if you remember calculus 101, the slope is the rate of changing, how the slope is changing. That's the rise over run kind of a formula. You remember high school stuff. So you calculate the gradient basically. So that gradient you calculate, and then you calculate, and you got to get to the minimum, so that it really really input equal to output. So input weight and output weight equal to should be same, then it becomes zero. So the mathematical concept, you don't to understand that. So there is something called global minima, and there is something called local minima. Your individual weight should be going to the local minima. So it's a mathematical concept, to be honest with you. I mean, people who have that kind of a background, they understood what I said. People who do not, I don't know. Probably I'll have to have a separate, math course for them. But I just cannot, bore you with all those stuff, local minima, global minima, all those things. But there's a no, that's very hard. Dr. Professor Andrew Ng, the deep learning expert, he has a lot of videos on YouTube. But he's even harder than what I explained. So don't even try that. His maths are really high. A Stanford professor, naturally. So now we are talking about Darwin. You remember we covered symbolism, symbolist, and then connectionist and evolutionaries. So Darwin algorithm. So what is thing is Darwin algorithm says it really learns from the natures of the fittest. So selection of based on variation of favoring traits and provide advantage to survival, reproduction is given environment. So you know that's Darwin law, like all those high school stuff. So basically, nature selects everything based on the survivor of the fittest. So in the Darwin algorithm can be seen as nature learning algorithm because it results the refinement and optimization of traits over successive generation, allowing organism to better survive and thrive in their respective habitats. So this is like a Darwin's algorithm in the species. Same when you're running an algorithm, you have to really find out which algorithm give you the maximum result, and you do it over a time and time and end. That's what the evolution algorithm means. And then when it does it and you refine it, and whichever that does better, that's the one you really select. So in machine learning, having like a brightness function is no brainer idiot. Somebody please mute your background noise. I don't know, some background noise I'm getting. So if we need somebody, please mute yourself. I'm getting distracted. Oh my God, I don't know. I don't know. People just don't do that, and this is.
Can you mute him?
Arvind Pal. I
Yeah.
think it's coming from the Arvind. Arvind, can you please mute yourself or let me mute him?
Just mute everybody other than the presenter. I mean, you have to do it. Our this thing is that they are, this is a little courtesy place. So when you are coming, this is all serious discussion. I get distracted. Okay, and if you
Yeah,
are
everybody muted now, Dada. You can go ahead.
okay. So genetic algorithms are less likely the background gets stuck in a local mean optimum, and so basically it's an optimal choice. Which algorithm will give you the best result? That's about it. Okay. So there is something called Baldwin effect proposed by psychologist James Mark Baldwin way back in 1890s. What the Baldwin effect says, the Baldwin effect proposes the organism that learned adaptive behavior during their lifetime have selective advantage over those that do not. So a lot of sea animals, they learn to swim fast or fast, so they are the one who adapted to the sea environment. And a lot of animals during those evolution period, they didn't learn to swim for whatever the reason. Either they got extinct, or they basically become land animals. They just don't go out to the sea and do all kinds of stuff like a sea sail and a fish and all those things. So this is that called Baldwin effect. Over behavior that learned and benefit survival may become genetically encoded. So over a period of 5,000, 10,000 years, all their survival mechanism, how to swim in the sea, becomes a genetically encoded, and basically they just, it's there. They just survive. Mountain goat. I am so fascinated with mountain goat. I always watch their YouTube video. I don't know how those, they have 4 legs, but I don't know, those legs like a paw, like a works like a vacuum cleaner or something. I mean, a vacuum kind of stuff. I don't know, but they climb mountains. They are steep, like a almost 90-degree mountain. They just climb. So because they adapted to that environment for whatever the reason, historically 10, 15, 20,000 years ago, now it's in their genes basically. So that's what I understood. So the Baldwin effect suggests that the learned behavior can be assimilated into organism genetic makeup. So this is all evolutionary theory. So basically, what in terms of machine learning context, that learning algorithms should be able to learn in minutes or seconds, and who learns first wins, whether it's Baldwin effect or speeding up the evolution. So all those machine learning basically is going to learning, right? So all the algorithms are learning, and those algorithms that learning really learn everything fast and really adapting. So that's kind of a evolutionary theory of algorithm. Those are the real right candidate for master algorithm. Basically, that's what it's saying. Those are the best algorithm you can run. So that's their tribe basically. So machine learning, the latest chapter in the arms life on Earth. The swifter hardware is only the half equation. The other half is software. So you not only have a faster processor like a TPU, GPU, and all those kind of things, and also you have the some kind of a software. Most of the goal of machine learning is to find the best possible learning algorithm by any means available, and evolution of the brain are unlikely provided. The products of evolution have many obvious faults. The evolution of the brain, human brain, we are not that smart what we are today. Think of it, that cave days, humans were not that smart. They were dumb basically. Probably if they could in those days, I don't know, they could really count 1 plus 1 or something like that. Slowly that brain evolved, they understood all those kind of things, but it took like some 500,000 years or all. So when you see those religious texts, like Adam and Eve, with all the religion, those are all bullshit. Scientifically, okay, it never happened. It never happened. Okay, scientifically, if you ask me, mathematically, it never happened. But people say it, let them believe it. Don't hurt their sentiment. I would never buy such theory. Okay. Anyway, so that kind of a evolution takes like a 500,000 years, and that's why it is smarter. For a machine learning, we don't have a 500,000 years. Okay, you don't take that kind of a process. It has to learn fast in second. So that is some kind of a things, and even all those evolution what happened, there are also a lot of faulty stuff basically. A lot of if you look at the species and all those biological scientists, they'll tell you that even many species there are a lot of faulty things are there. Means it didn't evolve properly the way it should evolve. So there's some genetic gap is there. So now this is the best part. I would like to spend a little bit more time, okay, with Bayes' theorem, which is a fundamental concept in machine learning that allows us to update our beliefs about probability of event occurring based on new evidence. So basically, the Bayes theorem is the mother of statistics. I would say that if you are a statistic major, probably you are doing this a lot. It solved a whole lot of problems. Okay, it's still being used in many a machine learning algorithm is the fundamental building block of machine learning algorithm, but there is a lot of refinement going on, a lot of new theories came. So Bayes theorem is just a simple rule for updating your degree of belief in hypothesis when you receive a new evidence. If the evidence is consistent with hypothesis, the probability of hypothesis goes up, if not goes out down. So there is something called conditional probability. Components of Bayes theorem involve three components: prior probability, likelihood, and the marginal likelihood. So this Bayes theory is basically concept of probability. If you have done the probability math, you are tossing a coin. That's the first equation you learn. The probability. You toss a coin 10 times. What is the probability of it will you'll get the head or you'll get 10? How many times? All those kind of a kids calculation they will the teacher will ask you to do, and you can mathematically define that. Okay, so in that probability there could be likelihood or prior probability. Before that, what happened if you toss the coin, how many times it will become head or tail, and what is the marginal likelihood. So I'm not going to all the details, but think of it Bayes theorem. Now, so this is a formula. This is a formula everywhere you will see it, and you might wanna go to YouTube or try those kind of stuff here. So this is the PAB that into PA divided by PB. PAB is the posterior probability of event A given evidence B. PB is a likelihood evidence given A. All this mathematical stuff. I'm not. So basically, let's go to an example. A Bayes theorem in machine learning is a spam email. Given an email is featured words of email, we can use Bayes theorem to update the belief about whether the email is a spam or based on observed feature. So when you basically spam email is the first problem the machine learning tried to solve. It's not 100% perfect yet, but to large extent it did. Because what happens is it does some kind of analysis of the email, an email subject, probably there is a lot of free stuff there or something, whether it's a spam or not, and they want to see that the person who is sending, his name is there or not, his email address, the domain name, what kind of email domain extension he is using. So all kinds of it goes like a last week in part 1 we analyze some 12 or 15 criteria. Google uses it and then it detects the spam or not. But all those criteria, you'll have to see the most likelihood it will occur or not. So it's all probability. It's probably whether this happened, probably that might happen. When A happens, probably B happens. When the B happens, probably C happens. When the C happens, probably D happens, or may not happen. So those kind of trade off mathematically you really need to do in order to even have a spam filter for your email, as simple as spam filter. And looking at like a Google, probably Google handles something like, I don't know, probably at least 10 million emails an hour or something. So think of it, how big would be the problem. So many probabilities and something like that. So one of the greatest mathematical of Laplace, then there's a dude called Laplace, and if you have done mathematics, it's a Newton's formula, Laplace connections. You still remember that same guy, Laplace. Okay, could comprehend all the forces by which nature is animated and respective situation of the beings make up. So basically, the Laplace principle in indifference. I'm not going to all the details of the math. Even I had had to take out all the mathematical equation because I thought no, it would be too hard for people who do not have that background. Even after taking out all the mathematical equations, still it appears like it's not easy to explain. But I'll try to at least explain the implication of it and how it is used. So Laplace principle of it indifference also knows that principles of insufficient reason is a concept used in probability theory to assign probabilities when there is a lack of information or symmetry among possibilities. Okay, here is an explanation along the rule of succession. So basically, the Laplace says, it's like a probability of basically the theory of assign possibilities. Okay, insufficient reason. There's a spam email. There are like a 20 different criteria set up, but still while you are doing this happen, probably that happened, this happened, and then there could be some reason which is insufficient to spam that email as a to flag that email as a spam. Probably it's a good email, like I'm sending you all of you to this Zoom link. Some of them do not get it. Some of their Zoom link, our email ended up, although I'm using one of the best software, the third party provider here, it's a $1 billion company. I'm using their email service. Still, that whatever the reason, Google send it to the spam. So a lot of people complain because that insufficient reason, that it's not spam, it's not in that equation kind of a thing. So it's to really detect as a regular email versus spam email. So it's still ongoing process. So you understand how this Laplace principle and indifference work. I'm not going into all those details about that, how it is work. So this is, I will read the many machine learning algorithms such as Bayesian network, naive-Bayes classifier, Bayesian optimization method are built upon the principles of Bayes theorem. So basically, Bayes theorem gave birth to so many other different kind of algorithm. Is called Bayes network, naive-Bayes classifier, Bayes optimization. All those things are there. So that's about it. I'm not going to get into all the details. It will really so naive-Bayes algorithm is a simple yet powerful classification technique based on Bayes theorem assumption and independent upon the predictor feature. Here's the next one. Bayes theorem, naive-Bayes release Bayes theorem, which describes the probability of hypothesis class level given some evidence of predictor variable. So whether the picture is a dog or a cat, that kind of a probability, Bayes theorem. Bayes theorem, by the way, nobody knows who invented it. Some mathematician came with that logic. That's what I found that. I don't know who invented it, but it's an extension of Bayes theorem, so it gives a better probability of reason. So there is another dude came called Markov chain. Is a mathematical model used to describe sequence of events where the probability of each event depends only on a state attained the previous event. Here is an explanation. So this is called Markov state. Here state A, state B. Markov chains consists of a set of states. So basically, this is complex stuff. But there's something called Markov state. Just remember. Okay, this is another logic basically. Okay, so I'm not going into this. But what is the Markov chain use? This is important to you. By applications such as search engine optimization, because search engine optimization, Google ranks page. And if you know what is search engine optimization, if you can really do it, you can make millions of dollars. Think of it if somebody says machine learning or deep learning tutorial, and I'm the deep learning tutor, and my website comes on the first. First, they see ad, people know those ads. They very 70% of the click on Google are not ads because people know those ads, and Google is honest. Google said these are ads. You just want to see that the real searches, and it's a machine learning tutors, and you see my name or my website address on the first, and you click it, and you come to our website, and you see what I'm teaching. Think of it, million people are coming every day. I'm getting million visitors, and even one person turns into student, even less than 1%, 0.01% becomes my student, I'll end up having a 1,000 student. Think of it. So that's a search engine optimization. It's an ongoing battle. How each keyword, these are all different keywords people type, and how each keyword you really rank. Your page should rank on the first, first rank 1, rank 2, rank 3, like that on the first page. And that too also, people just click first 2 3 links they see. They don't go below that. Sometimes they go, but 70 or 80% of the click they do is on the first 2 ranking. So if you put your company's URL and everything on different keywords on the ranking, you can really make a lot of money in terms of coming visitors, and whatever you sell, you do that. So search engine optimization is always ongoing battle, and Google never want you to be on the number 1, because Google loses money. Because if you are really getting free traffic, then Google is not going to make money from the advertisement. So they always do all kinds of mathematical calculation. If you are rank 1, they'll put you down through mathematical logic. They don't do even go for the millions of different search logic. So that kind of a search engine page ranking is done through this Markov chain. That's another example page ranking. So you understood that. Medical diagnosis consists also based in, and there's Markov network, which is an extension of Markov random field and a probabilistic graphics model. So basically, what we are doing in the algorithm is learning, and learning. You're running, going and analyzing your data and using some kind of a statistical tool to figure out whether this particular email is spam or not, or this a particular stock in the market would go up today or not, this particular, even if it is like a cancer kind of a detection, so this particular report is really cancer or not, or this particular x-ray of the lungs with the whatever is there is cancer or not. So all those, it just gives you some kind of a probability in terms of a degree of certainty, whether it's really 100% certain or not. So those kind of a mathematical tool is widely used in machine learning. So both Bayesian and symbolist approaches acknowledge the necessity of prior assumption, but the diverse in the type of prior knowledge they incorporate. In Bayesian methods, prior knowledge informs the distribution of a structure and parameters of the model. However, symbolist approaches offer greater flexibility. Prior knowledge can be expressed in logic, allowing for a wide range of input. Logic can be represent nearly anything, provided it is binary in the nature. Lot of academic stuff. Very easy. So what it is saying is, the Bayesian approaches, the necessary prior assumption, both require prior assumption. Okay, so informs the distribution over a structure parameter of a model. It just Bayesian model goes and find the distribution of the structure. All the models as the parameters, and it gets all the information of the structure. Like in this logical, this what you call a symbol is what the symbol is, a mathematical symbol, right? It works on logic that goes a little deeper into it. It not only gets into the structure of the parameters of the model, but also it allows wide range of input. So whatever the input Bayesian model is just one understand, it gets more input because it's a symbolic, it's a logical approach. So basically that's about it. Which one is super, which one is inferior, nobody knows. Probably, it's on case by case basis. The best part of it, you combine both. And the combining connectionism and evolution was a fairly easy. So now you got the evolution, that survival of the fittest, the algorithm that really learns fast, that does the maximum optimization based on all those Bayesian probability and all. And then your connectionism, and that's evolution, and your connectionism, all those back propagates and all. You can combine actually two different school of thoughts to make a new kind of a logic, this thing. So that's kind of a fast way to master algorithm. Still not there yet, because master algorithm, our brains doesn't do all this probability calculation or base and come on, our brain mentally doesn't do all those maths. Okay, so but a machine with the machine doesn't think like a human, because it doesn't have a human brain with all those neurons and all. So you'll have to simulate in terms of mathematical model, but still inadequate. That's the main concept. Just stay with that. Okay, so now this is something called, this is a very interesting from history. So in the tense depth of Cuban Missile Crisis, with the world teetering to the brink of nuclear Armageddon, President John F. Kennedy found himself grappling with the weight of history. So really, I don't know, I mean, nobody here probably born during that time, there was some 60s, or even if we are born very, very young, so probably infant or something. In 60s, there was a Cuba missile crisis. So the Russian missile stockpile on the Cuban, some place, some island in under the Cuba territory, and this is a history basically. And US knew that they were all nuclear missile and they were aimed at US. So who wants to strike first, whether Russia or US? And US, all the military and all the generals said, no, don't trust Russia. Don't trust Russia. Okay, those are guys are communists, they can do anything. Let's strike first and destroy them. But if that would start a nuclear war, and President Kennedy was, oh my God, what I'm gonna do? If I strike first, I would start a nuclear war. If I don't strike first, probably they might strike first. Still, will be in a nuclear war. Plus, it will take several of our cities, and that kind of things happen. But what he did is, just few days before, he read a book called The Guns of August. It's written on the backdrop of World War One, how those World War One started in Europe and it never ended, it prolonged. So President kind of related that story with the Cuban Missile Crisis. Why I'm saying this story is making it important, that some kind of a logic of deduction you relate with some incident or some historical incident. That could be a logic. So that's some kind of relationship thing. So what it does is, so basically inside the Kennedy analysis system, so saving the world from brink of disaster. So basically this kind of a relationship, that because that happened, or that could happen, that trigger happened because of this incident, may happen, not happen. So you are driving a logical conclusion of something, your brain is working in related to some another incident that related to that. Okay. and that those all kinds of a relationship theory also, that associate and all. I'll come to that in a later also. Just think of it, this is what, some kind of a so. And there is something called k nearest neighbor. This is very important, very used in many machine learning algorithm. And so k nearest neighbor is also used in large language model. It's a statistical tool. Basically what happens is you have the two class. So in a data, this thing, you always find the nearest neighbor statistically on a some kind of a xy plane. You can see, if which is your nearest neighbor. That means that one point, which point on the xy plane is nearest to the other point. That means if they are nearest to the other point, they are similar. Okay, that's called k nearest neighbor. So it's a little bit of statistical concept, but the k nearest neighbor is something what you call like a, suppose there are lots of picture in a that kind of a things, yeah, this is the k nearest near. There's an example, movie basically rating. So if somebody likes a movie and rates it on Amazon Prime and all those rating places, and he likes another movie, so in the data, so you find that who likes this movie, and if that movie he likes it, suppose, I'll give you an example, Lion King, the Disney movie, and who likes it, and then what are the other movie he likes it, and then you find some relationship, what is the nearest in the data plane. In the database you find the nearest neighbor. So you say, okay, this guy, Amit likes Disney movie, and in his neighborhood there is another guy called John. He also liked it. So John's like or Amit's like are similar. And probably John liked because Amit liked the Disney movie Lion King. Probably, John like also, another Disney movie, probably Lion King 2 or something else. And then it will be recommended to you. So because we are nearest neighbor, not in terms of physical distance, but in the data, when you are if you draw a XY plane, so you see that, and I don't know, I have this, uh, I don't know. I don't have this. I should have this this in graph. But whichever the falls in a some kind of a line on the XY plane, whichever the nearest, that's called k nearest neighbor. Okay, this is very important. And there is something called curse of dimensionality. Curse of dimensionality is this is a really big machine learning problem. Curse of dimensionality is when you have all kinds of dimensions. Okay, and it becomes computationally expensive. I tell you, giving an example. Suppose Facebook faces a lot this kind of example. Okay, now I put my picture on the Facebook, my profile is there, and Facebook wants me to suggest another friend related to my profile. So what the Facebook does is Facebook finds who are my friends, and Facebook find who are those my friends, and who are those friends like that. So it goes. But I like my friends, but that doesn't mean I like my friend's friend. Okay, I never do that. Okay, but because of this, similar k nearest neighbor, because I and my friends on Facebook logic are neighbor, and then it goes into different dimension, whether this guy is educated, where he lives, what kind of a college degree it has, what is age, what is his movie, liking, what he doesn't like, what kind of a post he makes every day, easy goes and post every day, or this thing. Nowadays, I was inactive on Facebook, okay, for many months, years. Now I'm very active because I'm I'm posting every day this 101 days of learning. So if you go to my Facebook post, it's all about this, whatever we are doing. That 101 days of AI learning festival, all over, all kinds of graph. So the Facebook figured it out. Oh, this guy is a machine learning guy, kind of thing. He's trying to promote it. he's also Facebook also, showing some kind of a related ad for that. But when you look at those kind of a dimension, Facebook needs to figure it out. This guy lacks machine learning, but what are the ads should fit so that I can click? Because at the end of the day, Facebook needs to make money. How Facebook makes money? When I click on their ad, whatever the ads they're saying, showing, so that the advertiser pay Facebook. But those ads may not be, because I'm a machine learning guy, I'm a AI guy, I'm teaching AI, doesn't mean like I'm going to, there's something called in Amazon race, that robot thing where you can really program and run a race car. Amazon has that. That doesn't mean I'm going to like that. Okay, that is related to my thing. But all the dimensions when it calculates, there's so many dimensions it calculates. So it goes beyond that, basically. That's called curse of dimensionality. A lot of dimensions you really don't need it. Okay, what is my skin color or height or the clothes I'm wearing got to do with my lacking of machine learning? There's no correlation, but those things will come in my profile. So many things will come. So this is called curse of dimensionality. This is so it really speeded, makes your machine learning expensive. It doesn't give you the result. So this is very important. Spam email detection. So even Google is doing that. So many dimension, whether free is talking about this, talking about content, what he's writing, what writing his name, or the signature there. So many word frequencies there, and in every and they're filtering, but so many dimensions of word. Free doesn't mean always the spam. If I send you said, hey, you guys are really good. I'm writing a book, but I'll give you a free book. So please come to my next class. And when you attend the next class, you'll be. I'm not spamming you. You guys are in my list and you're coming on the way. But Google figures out, oh, he said free, spam, boom. So that's kind of a curse of dimensionality there. So Google needs to consider all the stuff. So there's something called support vector machines, a popular supervised learning algorithm used for classification regression tasks. So basically, there's something called support vector machine. Very, very important. You can use it in the machine learning. A lot of things. If you are preparing for AWS AI/ML, certification, you will get at least 2 to 3 questions from support vector machine, kind of a concept. Okay, so if you're preparing for that, I'm giving you a little tip. Okay, so this is also some kind of algorithm, and it really reduce the dimension. Your ultimate idea is to reduce that unnecessary dimension, reduce that unnecessary dimension which you really need to reduce it, so that you get the right kind of a data to make a prediction. It could be regression or it could be classification. Classification, yes or no, binary answer. Regression means, when it gives you some kind of a number, stock market price is a regression problem. But if you say today it will rain or not, it's a classification problem. Okay, so it's yes or no kind of stuff. Remember that. Okay, so then I'm not going into all those stuff. Okay, now this is the place where I really want to do. Now we have come to the real world. Now this is very important. Stay with me because I'm going to cover few more things. You have to stay at least 10 minutes and then we'll be. So basically what happened is, now we understood so many logics and everything. Now what happened is, so there is something called supervised learning. So every time you show a missing a 1,000 picture of dog, 1,000 picture of cat, probably more. It's 1,000 is very less number basically. So and then it scans all the picture of dog or the picture of a cat. It convert into some kind of a number. Then it's all those numbers. It learns the pattern, and then once you show the another picture, could be dog or a cat, first it scans it, and then it understands what's the picture of the picture, and based on the whatever it understand the pattern, it compares the pattern it learned, and then it says cat or dog. Okay, that's fine. So it's always a supervised learning. So basically, when a baby borns, and this is a fascinating. I've been doing so much study on this. Okay, not because I was learning AI or something. Before that, also because I have a belief, and there is a scientific proof. Even Professor Andrew Huberman also saying this. MIT is doing huge amount of research on that. There is something in India called yoga nidra, and now they converted into some kind of a Western term, lucid dream. Bullshit, it's yoga nidra. Okay, so how we can really improve your cognitive function so that you can become a super genius, and if properly applied, I mean, I've read a lot of those kind of ancient stories. Okay, so this is my actually one of my goal in life. I don't know whether I'll be able to do it. It requires millions and millions of dollars, but one of my private research, I would train a child with yoga nidra, cognitive function, all kinds of technique, and all kinds of things, and so that the child learn fast, because child really learns without supervision. First, when the child is born, the baby is infant stage to up to 2 to 3 years, that infant doesn't speak, doesn't move, doesn't only sees and hear. That's about it. So it gets all kinds of a clue and to figure out, and then it learns. It learns the first word mama just itself. Nobody says say mama, mama, mama. We teach the dog like that, give a little treat. Dog say okay, handshake, this, that. That's what you do. But even the puppy also learns a lot of things. They get the clue from all the observation. When the infant becomes baby, nobody teaches that baby to crawl. It just crawls. Okay, so there is no supervision to learning. There is no teacher to learning. When it crawls, then it touches some kind of a hot stuff. Oh, this is hot. This is cold. It learns it by observation, by touching, that feeling. That's actually the human learning process. Now, if you continue, there's a way, scientifically way. Even if you, because after that, when the baby becomes 3 year old, then he start talking, speaking, doing thing. All those learning by observation really slowly decline. Now what the mama says, what the dad says, what the teacher says, that's what the baby learns, and also slowly learns what the other says, the adult says. Literally they become parrot. Basically, if you see a 3 4 year kid, they're just parrot. They just talk all the time. Okay, because whenever they learn new things, they just talk, and it's so light. It's really fun to watch them grow, but you try to understand the cognitive process going on. Okay, now if you stay with that cognitive process, and there is a scientific way to learn, and then if you put that yoga nidra and the lucid dreaming in that process, then the child by the age of 12 should finish college, by the age of 15 should finish PhD, scientifically possible. So we can this is another research. Probably if you want to join, we'll do it. We can really create super kids, but that's a different thing. Bringing that kind of a thing, say, how can we make that kind of a logic inside a master algorithm, so that the machine learns itself, just like a child. Can it feel? Can it touch? Can it smell? Can it hear? No. All you have to give it, you feed data, you feed what it touch. When it touch, probably it will touch, it will see it's a hot or not, but it's a touch through sensor. It doesn't have a biological hand or something. So all the sensor, then through that center, it gets data, so it's hot or not. Same, it's smelling. Now the when machine can smell, it see through eyes, through cameras, it hear, to all kinds of a sensor. But there's no biological sensor that through that it learns itself. And that's the problem. You see this, why it is taking so much time to get into singularity. The first slide, remember the first slide? So actually he said non-human, 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 because all these are non-human, not human. Human machine learning becomes human the moment it mimics the actual intelligence, one single logic, and most of the time it learns by observing. not through center, not through data, not through all those things. And that's the kind of a things we are getting into singularity. Mathematically, can you go there? There is a possibility. How fast we can go there, we don't know. Even if that launch, will it have a human emotion? Absolutely no. You cannot teach missing a human emotion. Outside the human, okay, if you take that human emotion out, like a feeling sad, something, it might observe, it might say, you remember that the Star Trek, the data, that character data, that dude never had a human emotion. He used to learn, he used to say, talking to Captain Clark and Mr. Spark and all those things. My favorite, basically, show in the TV. I would never miss that Star Trek, the old one. Okay, Spark, Mr. Spark, and all those guys. So, but the data, he was a humanoid. Just to call some kind of a robotic. He would never feel the human emotion. So that's going to happen. But close to that, how fast we can go? Okay, not feeling sad, not feeling, happy, those kind of a human emotion. It can understand, but it could never feel. But other than that, close to that, how we can build, how a child learns. When a child learns the way an infant learns, if you can bring that logic into the machine, it becomes master logic, master algorithm. That is what we are talking about. That is becomes human. Makes sense? So there is some concept here, trial and error, long language acquisition, whatever I said. So this is how the infant learns. And there is something called K-means popular clustering algorithm. So basically what we are doing is we are just, what you learn, how you can do that. You learn through clustering basically. You cluster stuff. Okay, when you cluster, we go out, when I go to the market, and when you go to the some grocery store, oh my god, probably you go to any, I don't know in other countries, but you go to any grocery store in like a Safeway or here in Bay Area in US, most of them are probably at least 250,000 to 500,000 items are there, from milk to bread to seafood but all those things are now grouped into special things: seafood section, breakfast section, produce section, and then your pet food section, your meat and all those things section. So now they're all clustered and grouped into different section. And then you go particular section. Even if you go to the milk section, there are other groups also within that sub milk section. There is subsection. There's organic milk. There is regular milk. There is a 0% milk, 2% fat milk, 10% fat milk, and then your what you call the other milk, that almond milk. So many varieties. And those are even subsections. So it's a clustering. Everything we learn through clustering. We cluster stuff inside our brain. And that's the way it is. You always cluster something there. Otherwise, it's just crazy. It could go crazy. You just cannot go to the supermarket or anywhere. You cannot learn everything, anything other than you, unless you cluster. You're learning everything here right now. You're clustering. You're focusing, machine learning, this thing. You're not learning math, statistics, everything. Although I'm explaining everything, but we are just clustering 5, 6 different neurons. These are different subject areas. We're assembling it, different clustering we are doing. So that kind of a human brain thought process is something you can do mathematically, and that's called K means. I'm not going to show that. And there is another mathematical concept called principal component analysis. Very good. This thing can do a lot of principal components in a some kind of a figure or some kind of a data. You have to reduce that dimensionality, curse of dimensionality, by taking out all the irrelevant data, and then you see which are the main data you really want to do. Those are called component principal. So you reduce a lot of noise. Okay, I'll give you an example. You go and try to everybody goes there to receive their loved one at the airport, your spouse or probably your father, mother, or your brother, sister, or your friend. And we go there to the airport, aircraft landed, and 5 or 6, to go to San Francisco, always crazy, but like those kind of airport, at the same time, 10 aircraft landed, and probably some 1,000 people are coming out. And then you have to really spot your friend there or your brother there. You are going to filter everybody. You see everybody, all kinds of people. You look for, oh, that's my friend. Hey, man, how are you doing? You do that, right? That's principal component analysis. Think of it. I'm just giving you the analogy. Okay, so you just take the relevant part. You filter everything. See, in the learning process, all the data you see, you filter all those irrelevant part. Whatever that you need it, these are the things I need for my machine learning calculation, prediction, whatever. These are the component. This is called principal component. The mathematically you can do this. Make sense? And so I get this, and there is something called reinforcement learning. Reinforcement learning is very important, and it's really all the games and video games are really based on. It's some kind of a digital and this thing. Okay, deep learning network. I'll cover reinforcement learning a little bit in my deep learning class. So what you is reinforcement learning means reinforcement is a behavior. Okay, a lot of people, and this is a real life example. If you want to stay out of distraction, okay, so what you do is put your cell phone in at least for next 10 days out of your sight. You are not going to touch your cell phone. You tell your wife or your friend or mother or father, say, don't, only you take my call. I'm not going to, I switch off. So what happened is your behavior to go all the time, use your social media all the time, checking, messages, WhatsApp messages, that impulse will die because your negative behavior, actually it's a positive behavior, your weakens your negative behavior. That's called reinforcement. It's always applied in child education, is always applied in military. So whatever your negative behavior is reinforced by positive behavior. The same kind of a logic is applied in the kind of algorithm. So what the machine is rewarded basically. And so machine is rewarded based on the what machine is learning first. And if it makes a mistake, the algorithm is not rewarded properly. It's all done mathematically. Game, people who develop a game, they know. So game moves like that. This without reinforcement learning, you can create some kind of a computer games. Okay, at least the modern type of things. Okay, so that kind of behavior you can put it in the algorithm. So reinforced learning. Then we talk about relationship. We remember first I showed you the relationship about different. We learn things about relationship. Okay, I'll give you a very simple example. Like we associate things. You go and take your. You're going to a mall. Okay, and then with your spouse, and then you see a theater hall, and then when you see the theater hall, immediately your brains remember, oh, you came to the theater after 2 weeks because you wanted to bring your kid for this thing to see a movie, and you were rewarding your kid because he was punished before that. So your brain associate things one after another. Then he was punished because he didn't do homework. Why he's not doing homework? If you are a woman, it's his dad was not helping, his dad watching the games. And if you are a man, she was always talking on the phone with her friends. She never paid attention to her kid. Fight starts. You are in a good mood. Fighting started because you're mentally you saw the movie theater, and then one after another chain of past event happened, and then it goes to some kind of this thing. So this is all relationship learning. You learn certain things with relationship. I gave you that example. I also gave you a lot of example about the grocery store, about clustering. Now you can relate. That's called relationship learning. We learn through relating things. We cluster things, then we learn. So that is called relationship learning. So if you can get that thing into machine learning, master logic, probably you can have human intelligence. So these are the different way. So I would say this, and I will just talk. I'll just explain that this is the last symbol. Basically, you can see this. I'll just explain it 2, 3 things. So you have the analyzer. Remember, in the first slide, is symbol is connection is evolutionaries and Bayesianis. These are the 5 tribes of artificial intelligence or machine learning logic. And then, are they important? All of them are important. At the same time, what it happens is actually it is boiled down to representation, evaluation, and optimization. So which one is better, which one is not better, how we can use it to create your master algorithm. That's like a things really a lot of research going on. But what mathematicians figured out that all those data analysis from where all the pattern learns, actually it's a representation. You have to represent some kind of a data, some kind of an algorithm, and then all those different kind of algorithm you are evaluating. Probably you are working several different kind of all this your master algorithm, probably using all school of this, all the tribe, all the different algorithm. And master algorithm is like a boss. That boss is deciding which one is better on what context. One context, one algorithm will be better. On the other context, that algorithm may not be better. So that boss decide, and then it represents and then evaluates which one is better. Then it optimize. It gives the maximum result, giving the minimum power or minimum input. So that's what the master algorithm concept all about. There's a whole lot of research going on, and then I have another stuff to do, but I think I would call it a day because you already, thanks for staying up here in US and other places. Okay, so we have really covered a lot, and probably I took more than I was supposed to stop at 8:30. We already started 20 minutes late, so basically, but that's okay. Even last time also, I told you that I at least have half an hour really in mind. Whole lot of things I covered basically. I covered everything basically. Everything, every logic I covered. If you watch the first one, this one, all how machine learning works. I didn't cover all the mathematical details. I didn't cover about all those nitty gritty, but now you understand all the school of thoughts, how the school of thoughts are working, what is the non-human intelligence, what is the human intelligence, how a child learns, how those that capability, the way the child learns through observation. If we can put that kind of a logic inside the master algorithm, then it will be a human intelligence. From non-human to human, there's another, it will start I think from 2040 onwards, something, that singularity thing. So another 15 years from now it may happen. I have everything to believe that it will happen. I have already figured out another, I thought of it. I need a lot of funding. I want to create a master algorithm for engineers. Every little thing, every engineering knowledge, everything will be put into some kind of algorithm. And then, from aerospace engineer to architect, all kinds of algorithm will be there. It will run. It could be humongous stuff. This is I've been thinking for last 3-4 years. Anybody is interested, and if you have a lot of money, talk to me. Probably we'll do something else. Probably we'll have to get some government fund for that, but that is also another thing I'm thinking about it. This huge thing. Thanks about it. If you want some question, I'm here to take all your question. Otherwise, we'll just stop it. How was it? And everybody can now unmute yourself and talk. No problem.
Your enthusiasm is very good.
Okay, so all you have to do is Sachin, you please, everybody please, probably I'll send another email because it's too late. I didn't do this. Because you joined the Discord, people who haven't joined the Discord, I will upload this how to join Discord tomorrow morning. There's another technical session, you can get it. And so and then whole lot of things we are covering basically. but at the same time, we really need your, encouragement. So come and say whatever you learned or whatever the way it is going on our Discord channel, and then you can give your name. If you can even don't want to give your name, but I would prefer you give your name, and then we can really publish on our website that these are the way people are saying. So a lot of people are not trying to join. They want to join because they want to see if there's any value to it. You guys, if you find some value, then you should speak out, and then give your feedback, and then we can really take it to the next level. All right.
Yeah, it's a very interesting session, Amit, and I hope everybody has enjoyed it. It's too much to digest, but at least they will get a feel what's going on in the how people need to negate to it. That's a
No,
wonderful thing. It needs a lot of time to digest it. But do you suggest some other article or some kind of the other stuff that they can, expand their knowledge on these topics?
I would suggest go and watch all the Jeffrey Hinton's videos. He's very good. His videos on the YouTube. Okay, Jeffrey Hinton, Professor Newen, and there are many books also. Okay, they can also read it. Okay, so see this is see I tell you this. I mean, some people say, how did you learn all those things? No, I didn't learn. Why I didn't learn? Because I never wanted to learn. I really never wanted to learn. I want to get into it. And when you get into it, you don't learn.
And
You
one more
get
thing,
obsessed to it. When you get
yeah,
obsessed, so you have to convert. People are say I'm passionate. No, passionate is not enough. Passion will take you to some level, but you have to convert your passion into obsession.
absolutely.
When you convert your passion into obsession, things you learn, but you learn effortlessly because you are obsessed to it.
So,
Your focus will be naturally there. So that's the key basically.
one thing, Amit, what we can do is,
Next morning session means our morning session. For in India it's your evening.
yeah. No,
Somebody.
one more thing. What we can do it. We can ask, who have attended the session today. They can make some kind of the tabular form, write down the theorems, what you have told it, and come out with an example, live situation where we can use the AI
Mm,
and which kind of the theorem can be used in which
mm.
example. So we can have a more, interactive session, and
Yeah,
somehow
yeah, good. Basically, I we covered like a 2 hours, 2 hours, 4 hours. To be
that's right.
honest with you, the master algorithm itself is at least a 1 week of lecture.
No, absolutely. Yeah, you cannot cover everything in this
Mm.
one, but yeah, that's the reason why what can they extend
Mhm.
the further reading and how can they come out the real time because they need to use those theories into the examples, right? If
Yeah,
they
so basically, what I'm doing because we are putting up all the YouTube, or not on video.
Hmm.
Okay. Uh, Sunday morning 8 a.m. Somebody asked Sunday morning 8 a.m. not 7 a.m. Time change. Okay, we already sent everybody the email, so you should get it. So whatever is basically whatever what you call I discuss all the videos will be there. Go and watch the videos, take notes, takes whatever I said, support vector machine, the markup chain and the base chain. Take those, even you can stop those slides are there. Try to read those slides. You'll understand. I just skip through because I didn't want to bore you. And then whatever, you just stop the video, slides you can see, read the slides, and then you do your own research, find that similar concept in YouTube and others, how people are saying it. That's the way you learn basically. Everybody learn. So 8 a.m. PST, yes, and next session, whoever registered through our registration will get the email link, and people who came through our AWS meetup group, I also post email Zoom link there. So tomorrow morning, 8 a.m. PST is our time, California time. And then even I sent a email to everybody. This is the time change and this is a time converter, how easy it could get. Wherever you are, you click at, put the PDA time and your local time will show. Even I sent that link. Did you see that? Okay.
Yeah.
So people, go and look for your email. If you don't get your email, that unfortunate. But at least people who have subscribed to our this Discord server, I also put whatever I send, email I send because of the spam filter on, they do not get. I have to put it on the Discord server, which is there, which is always there. So you will never miss it. So if you have not signed up for Discord server, please sign up. I'm going to send you another. Today, Nishna, actually, our trainee, he has an exam. He does that. He's not there. I don't know that instruction where it is.
Yeah,
I
he's
don't have
here.
handy.
I think he joined. So I think Kapil has a question. Kapil raised the hand. Kapil, do you have anything?
Ravi joined. He has an exam, right?
Yes.
Kapil is saying something.
Yes,
Yeah.
Kapil.
So, Amit sir, is it possible to get the slides of last two sessions of master algorithm? Because these two sessions have been intense and
Yes, yes. I mean, see, I tell you this. You are part of the team. I'll share with you, but I promise with this thing, these are all our intellectual property. We can only share with the team members, not whoever joined. Video is there, you understand, right? Okay, I'll share with you because you are part of the team who are in the our this thing, but not with everybody. I make it this. Why I'm saying it? Because it goes out and then I mean it's not nothing bad on it or anything, but we are trying to create some kind of an ecosystem where people come and join and all, and then come and discussion. And when this thing gets
public.
all over the places, they go, oh, we already got a presentation, who comes there? So that will kill our purpose basically. Okay, so we'd like to keep it that way. I'll tell you, I created, I mean, I used to take the AWS classes, right? And then I recorded it and give it to my students, and and probably they shared with somebody, and somebody from Bangalore after 3-4 weeks said, we watched your video. I said, where? He says, we know it's everywhere in Bangalore. Okay, so it's already reached there. People started watching it. Some people even put it on the YouTube channel. Okay, all kinds of things happen because I didn't put it on the YouTube channel. I cannot claim my copyrights, although my voice was there. Okay, and everything. But anyway, I mean, I learned my lesson. So, in order to restrict that, what we do it will that video access, everybody will get it. They can stop. When they stop the video, still that will be they can see the screen right on the screen there, and they can take the notes. But for you, because you are part of the team, I'll share with you.
Thank you, sir.
But for others, I'm telling you, right? So they will get the video access. It will be on the Vimeo. Our intern, he just he has an exam today. That's why he couldn't come. When he comes back after exam, we'll set it up. There's a whole lot of editing needs to be done. So you have to give us some time. I don't know, a week or two. But everybody will get the access to the video so that they can watch it again and again. So basically, what you do is you go to Indian engineer. Just a minute. Let me write it. Somebody say dot. This is our site. Go to our site, and then there is 101 days of AI learning. You will see that tab. Click on the tab, and you will see a registration form. It just will require your email and name, and it will be, and you register. Then you have to opt in. There will be email confirmation. Once you opt in, it takes like 2 minutes. You will be in our database. Every little email you will get. Okay, so you have to register for that. Okay. All right. So anything else? I think that's about it. I had to cover a lot of things, and thanks for all your patience. But it's really was it interesting?
So,
Very.
Dada,
Yes.
Amit, we have one Vishal He's joining from Pune, and he's a faculty in one of the engineering college, and a mechanical engineering faculty.
So Bisalji, you join us because we are like to open some chapter in engineering college. You
That's
don't
right.
need any rather, and we are not promising now. In future, probably we will also help them locally in terms of little bit of funding and stuff like that. We just got registered, but right now, and also we are looking for 2-3 good interns. So if you find somebody, because what we are doing is, Bisalji, we are Indian Engineers Without Border. It's a very, very large organization is going to happen, but we are already talking to large company. MongoDB already has become our partner. He's going to come and talk about vector database. AWS is partner. We are going to bring a AWS speaker, and then we are Silicon Valley. It will go to Google and other place. What we are doing is we are recruiting intern, and then we will train them, and they will have to work with us. But we need very, very serious guy, not like like a guy who is always doing Netscape, what is called that Facebook and all the other one, Instagram and all. No, very serious type of people who can really join, because this is a grueling subject. You saw how grueling it is. You are a professor, you know that. Okay, you know that how grueling it is. At least you know. Okay, all those mathematics, all the gradient descent, this, that, all grueling stuff. Okay, if that serious player they want to learn, they will join our ecosystem. I will personally teach them. I will, free of cost. That's my guarantee. Nobody, I'm expensive, by the way. If somebody asks me to teach somewhere, I'm very expensive. So they'll get the free teaching. Okay, and then we'll prepare them for hackathon. We'll prepare them, and then if they, before they complete their degree, I can guarantee if they come up to the hackathon, they'll have a job. Okay, we cannot guarantee in here in US. We'll bring some people on to US and Canada. We are also talking about that. That's a separate thing. That's a more of a commercial arrangement. But definitely with our training, they will get a job through the hackathon. They'll get the certification. There will be very, very rigorous vetting process. Basically, if you go to our website, it says we are going to create world top 10% AI talent, and that's going to happen. So if they want to be one of the top 10% AI talent, they're welcome. We'll make them happen. Okay, because it's a win-win situation. They will get a career. They're all young boys. They will get a career. We'll get good people. We need, because we are doing so many stuff there. Okay, so we really need. Okay, so please join us. Bring your student, as many students. Let them at least compete. It's a 2 hours in the morning, 2 hours in the evening on Sunday. And if they really are, they're studying engineering, if they cannot spend 4 hours, I don't know, because by that time they graduate, become, get their 4 years degree, everything will be obsolete. You know that, everything, whatever they are studying, when they get out, they will be jobless basically, because 300 million jobs will be, eliminated, not eliminated, will be replaced. And the good news is 300 million jobs will be replaced by 400 million jobs, but all related to AI skills. So even that dude is a mechanical engineer. He thinks, okay, I learned a drawing, I learned engineering thermodynamics, I know how the carburetor works, and I know how to put that job on the lathe machine. I can do the calculation. Oh, I'll have a job. Sorry, sir. That's his wrong assumption, because when he comes out, all those things will be automated by AI tool, and he needs to use those AI tools. Okay, your mechanical engineer, think of it. Okay, goes to a company, everything is automated. From CAD CAM to all those machine automation, NCCNC machine, all the NCCNC machine, probably in college he has learned something, that NCCNC programming, but now they are all automated with the, robotic arms, robotic process automation, and all those AI tools and all. But the guy, he doesn't learn all those things in the college. Because that college, to be honest with you, you're a professor. I don't want to say anything bad about any professor teaching stuff. Okay, you guys are doing very great job. But most of the professor all over the world, it's not only in India, are little bit behind. little bit behind. Some of them in a lot of, I don't want to say it, but I've seen it. People in IIT and other place, they did their PhD 25 years ago. Who cares? If they're not relevant, who cares? They're not relevant. Khatam. So what they are going to teach their student? Okay, so here in US at least, the research oriented institute like a Stanford, MIT, they are doing the forefront research. Their professors are always updated because they have to retain their job. There's something called tenureship, all those things, not there in India. Okay, so there's a huge gap with the technical training in India and what's happening. There's a huge gap. I know that. I'm living it. Okay, so we want to bridge that gap. We want to collaborate with the professor, train the teacher first. These are the curriculum incorporate. These are the things you let your student learn. You also learn in that process, so that everybody wins. You as a professor become always relevant. You're still relevant. You're part of the ecosystem. That's the reason Indian Engineers Without Border has been formed, because we are like to create an ecosystem of that, so that we always stay on top of that. Make sense?
Yes, sir.
Okay.
We generally teach the fundamentals, but practical aspect we should learn from the industries people more.
Yeah.
That's my.
Yeah. Not only fundamentals, even fundamentals is always, the theoretical knowledge is always good. Everything is nothing wrong. A guy should have all those fundamental knowledge that I'm teaching a support vector machine, or I'm teaching some kind of deep learning, and the person doesn't know what is a gradient descent. That's it. Then I have to teach him all the maths. So that's that. But those are the things expected. He should learn in the college and come here. But so your college, or your teaching staff, not only your college, all the colleges across the world, they're building that foundation that is required, absolutely required. But after foundation, what? They have the foundation. After that kind of a, so there's a gap between the foundation and fundamental knowledge, you rightly says, and the actual what is happening in the industry. So we as an organization practicing engineers, we're trying to bridge that gap. Okay, so I
Yes.
always encourage you about asking your student, and there's something called think like Wright brothers. Okay, so I talked about it, how that engineering reasoning, engineering this thing, I said a lot of things, how it is happening. Okay, so some of them, but I even said this, that college degree is becoming absolute. That doesn't mean college degrees are absolute. What I said in terms like a college degree should be updated, upgraded, otherwise it is becoming obsolete fast. Okay, so that kind of this thing we really need to do. That is what basically I'm just talking.